Let's talk about connectors and remote networks in TwinGate, what they are, how to deploy them, and how you should think about connector placements. So what connectors are, right? Connectors are very small software components. They're typically deployed as virtual machines or containers that act as proxies and proxy connections from the TwinGate clients to an endpoint that is either private or public. If you have a private server that exists as a TwinGate resource, when a client connects to the resource, its connection really goes through the associated remote network, is proxied via one of the connectors on that remote network, and then sent to its final destination. And then when the traffic comes back from the resource itself, it goes to the connector, and then the connector sends it back to the TwinGate clients. That's essentially what a connector is. Now, a connector always lives within what's called a remote network. And a remote network is really nothing more than a cluster of connectors that act as a load balancer and provide high availability across connectors. That's the only thing that a remote network is. If you take a look at the admin console, here's a demo environment we have. There's many remote networks here. Some of them are hosted on AWS, Azure, GCP, or on-prem. And a given remote network, let's take a look at this one. This remote network happens to have 3 connectors. We don't need this one, but we could add a third connector if we wanted to load balance across 3 connectors. The connector, again, is the remote network is assigned resources, and all traffic for all of those resources is going to be served by either of those 2 connectors, depending on the user and depending on the device. Now, when you want to deploy a connector within a remote network, it's very simple. All you need to do is add a connector, although when you create a new remote network, the remote network will come with 2 pre-created connectors for you. Click on the connector that hasn't been spun up yet. Pick a deployment method. There's lots and lots of ways to deploy them using command line, using various different platforms. Probably the simplest one is going to use the Linux flavor of the deployments. The only thing it does is really it'll generate 2 authentication tokens that are unique to the connector. And it'll give you a command that you can run in a VM, for instance, to set up your connectors or set up the connector. Once you take the command here and run it on a machine, it'll take anywhere between 15 to 45 seconds to be online and start serving connections from clients to resources. That is what a connector is. Now, there's a few considerations to remember. So again, connectors are always part of remote networks. A connector is only ever part of one remote network. Resources are attached to remote networks. A resource is always attached to one and one only remote network. Now, for prerequisites for connectors, what you need to know is that all of the resources that are going to be attached to a remote network, they need to be routable from all of the connectors in that remote network. That's prerequisite number 1. So if someone from the IT group who has access to resource 192.168.3.4, and if this resource is attached to remote network B, it means that both connector 3 and connector 4 need to be able to route traffic to 192.168.3.4. Prerequisite number 2 is only applicable if you use DNS-style resources. So if you have resources that are declared as something like server1.corp.int, when a user from the IT group connects to this resource, and if this resource is attached to remote network A, it means that not only connector 1 and connector 2 both need to be able to route traffic to server1.corp.int, but before they can route traffic to the endpoints, they need to resolve server1.corp.int first. So the second prerequisite, if you're going to use DNS style resources, is that both your connectors need to be able to locally resolve the fully qualified domain name to its actual private IP so that they can successfully route traffic to the endpoint. Now, that's pretty much it when it comes to remote networks and connectors. We don't have hard prerequisites on how to place connectors beyond the prerequisites we just reviewed. We do recommend customers to place their connectors as close as they can to resources they serve. It just shortens the distance between the client and the actual resource. But that's the only prerequisite. We also recommend 2 connectors per remote network. You can scale that up if needed, although it's very, very rare that you would need to do that. You can absolutely run on 1 connector per remote network, although we don't recommend it because if 1 connector goes down for some reason, you may lose connectivity to the site. So that's why we always recommend 2. The load balancing that connectors offer within a single remote network is not a load balancing of connections. It is a load balancing of devices, which means that if you have a pool of 40 users collectively using 50 devices that are all connecting to resources associated to remote network A, then you have a strong chance that about 25 of those 50 devices are going to build an affinity for connector 1 and typically connect through connector 1. And the remaining 25 devices, the other half of that, is going to have an affinity for connector 2. That's how the load balancing works at connector level. Now, when you deploy connectors, before they come online, right? So before in the admin console, you start seeing them as green, right? They report a controller and relay connection status here that is connected, which is great. You have to fulfill some prerequisites. So in TwinGate, there is no requirement to ever open an inbound port anywhere because we consider that a huge security risk. So you'll never have to open any port to the internet. What you need to do for connectors, though, is that connectors need to be able to outbound to a few things. So your connectors need to be able to outbound over TCP on port 443 and port range 30,000 to 31,000. That is because those port ranges are where we host our relay infrastructure, and connectors need to establish a connection to our relay infrastructure so as to facilitate peer-to-peer traffic between clients and connectors. The second thing that needs to be there is that connectors need to be able to outbound over UDP on all IPs and all ports. The reason for that prerequisite is because we allow for peer-to-peer traffic between TwinGate clients and TwinGate connectors by using something that is called NAT traversal via the STUN protocol. And for this to work, since there's never any predictability as to what public IP addresses the TwinGate clients are going to bind to, it really depends on the internet service provider of your employees, then the connectors need to be able to connect to all public IPs over all ports. That's a prerequisite in NAT traversal, so as to establish peer-to-peer connectivity. Now, the final requirement is to not block the QUIC protocol, which is sometimes the case on some firewalls by default. The reason we use QUIC is precisely for peer-to-peer communication, because it's much faster. And so we recommend not to block the QUIC protocol. Now, if you do block the QUIC protocol, TwinGate will still work, but the communication will be relayed. So it's just something that you should know before making a decision and checking whether QUIC is blocked or not blocked.